Hi guys, for today's lesson we're going to be dealing with congruent triangles. So firstly, what do I mean by this word congruent, or in general congruent shapes? So it means two or more identical shapes. So the word congruent refers to this word identical. This is the symbol for congruent. So it's kind of similar to an equal sign, because equals means like the same thing. Congruent is very similar. Instead of 2 lines, it just has 3 lines. Okay, some rules to remember. We do not need to know much about a pair of triangles in order to conclude that they are congruent. So there are 4 conditions or tests that can confirm triangle congruence. And you only need to show one of these tests. You don't need to show all of them. You just need to show one of them to show that 2 triangles are exactly the same shape and size. So if you know that all 3 sides of 2 triangles are the same, side, for all 3 sides, that is enough information to show you that these triangles are identical. So you don't need to know anything about the angles. All you need to know is that you've got these sides matching each other, and we can conclude that that this triangle is identical to this one. And the way that we write that is what we've got under here. This is what we call like a congruent statement. We're saying that triangle ABC, this one here, is congruent to that symbol there, 3 lines, triangle FDE, as you can see here. Okay, question 2, SAS test. So that's when you have a side, an angle, and a side. So if 2 sides and their included angle of the triangle are equal to 2 sides and their included angle of another triangle, then they're going to be congruent. So have a look at this triangle. We've told you that this side is equal to that one, that angle is equal to that angle, and that side is equal to that side. So we can say like side, angle, side. Then it's going to satisfy this test here. It's really important to understand what the included angle is. The included angle is the angle that's between the 2 equal sides. So because this equal angle is directly between these 2 sides, which are also equal to each other, therefore that's the included angle, and it does satisfy this this test of side, angle, side. If that angle was instead here, and like we were showing that this angle and this angle and this angle were the same, we wouldn't be able to use this test because it needs to be the angle which is between these 2 sides. And again, there's our congruent statement for these 2 triangles. Next one is angle side test, or AAS. So if you have 2 angle pairs with your 2 triangles, and you've got another side which is the same, like a side pair, that is enough to satisfy this test and show that these 2 triangles are congruent. Next up, the last test is called the RHS test, or the right angle hypotenuse side test. That's pretty much means if you've got given that the hypotenuse of both triangles are the same, you've got given that a side length is the same, so that's not the hypotenuse, and you've got given that a right angle is the same, like they've both got right angles, that's enough to follow this test. So there's your congruent statement. Note, a really big note with this test here, is that this is very similar to the side angle side test, because you're dealing with 2 sides and an angle. However, notice that the right angle is not the included angle. So this angle is not between these 2 side lengths. So yeah, that's kind of the difference between the RHS test and the SAS test. So pretty much like these triangles can be congruent if the angle is not the included angle, but obviously that angle has to be a right angle. Okay, so let's do some example questions. So determine which test can be used to show that the following triangles are congruent. So what we've got here is 2 triangles like this. You can see here that we've got a pair of sides the same for both triangles. They're both 6 meters. This one has a pair of 12 meter sides. They're the same. and we've got an angle that being the same. So we look at this and we think to ourselves, well, we've got a side and another side which are equal to over here, and we have the included angle of these sides also equal. So these two triangles satisfy the SAS test. So side angle side test. So that's going to be the test you're going to use to show that these two triangles are identical, they're congruent. Given that triangle ABC is congruent to triangle EFG, so that triangle is the same as that triangle, find the value of each pronumeral. So the idea is we can see that these two triangles are identical, and the way that even though they're kind of in different positions, like if I take this triangle here and if I rotate it, I can kind of like get the same shape. Like I could pretty much lie it on top like that. So I'm pretty much just rotating it to get to where I need to be. So so we can see that they're identical, but they're just in a different position. So we got to figure out what these values of x and y are. So again, if I pretty much rotate it, I can see what those values of x are going to be. So when I rotate it, I can see that my x is going to be that angle there, that 85, and my y, upside down y, is going to be that 35-degree angle. Okay, so that's pretty much what you want to do. So your y is going to be 35 degrees, and your x is going to be 85 degrees. And I put these reasons next to it, and the reason is because this angle here, y, that corresponds to that angle. They're both kind of like the pointy part of this triangle, like it's the sharpest like sort of angle, the smallest angle. So, and that's the same over here. So that y can like matches up with that angle there. So therefore y is going to be equal to 35. And the same sort of thing applies for this x angle. That 85-degree angle kind of swings around and is the same as that angle x there. Hope this helps you with the questions. Good luck.